All right, step one is to add data from the Living Atlas. I just navigated to the Living Atlas here, and I'm just going to search income and look for something that's county level. Just as a hint, I don't know if you do something weird here and bump this, sometimes it'll be sorted by something else, like date modified, which really doesn't help. Make sure it's checked to relevance so that the best matches come up first. But we're going to go ahead and use this census, the median household income variables, the boundaries, not the centroids. I usually just highlight it and hit OK. Sometimes there's other stuff embedded in there, and that keeps it simple. We just want the county. We don't need the tract or the state level. For simplicity, I would just go ahead and remove these. And then to copy these, which you're going to need to do a few times here, you right-click, copy, and then you can go to the map, right-click, and paste. It's a little bit not intuitive. Usually you can just kind of Control-V, but it doesn't work in this case. Okay, and then next we're going to work on symbolizing these. We want to classify them. Right now they're drawing as unclassed data with a divergent color ramp, which is interesting that it would default to that because it's implying that there's some sort of neutral or midpoint that's meaningful. So if you have county highlighted, you can go over to symbology, or you can just right-click. Oh, mine's closed. So right-click to open the symbology. Okay, this is my default setting. I'm not sure if it is going to appear the same for you, but because it's unclassed, this is our symbology, primary symbology type. It's defaulting to median household income in the past 12 months, and then inflation adjusted, which is really the first meaningful field, which is great. That's what we want to be working with. Divergent color scheme, but notice the histogram down here. The X is marking the average. And notice that the neutral point isn't aligned with the average. So that's really, Tableau would never do that, people. That's just crap. So we're not going to work with unclassed colors. I want you to explore working with graduated colors in a classified setting. So the default is natural breaks with 5 classes, but notice that the field just changed to the area. So again, that's just dumb. But we're going to change it back to that first field, the inflation adjusted median household income. It's still natural breaks with 5. Now here you can see the range of values. You know, in the old one, it said, you know, anything greater than almost 100,000. But you can see that the max value goes up to $142,000. So that's pretty different. It's interesting, I think. But now we've got the classes here, and you have to toggle over to the histogram. The histogram is going to be critical in this classification stuff that you're doing. This is what we want to be looking at. This is our range of values. Here's the histogram, and what a great legend this makes, right? So if you build a regular legend and it ends up looking like this, that's interesting, kind of. Look at all those numbers, stupid. You're not even gonna figure out what this means. It's just too messy. But wow, this is fantastic. We can see the distribution of values, and we can see how the classes are set up. Okay, so here is our one classification scheme. And let's go back over here and force this guy to draw. Okay, so here's what it looks like with natural breaks. The map makes pretty good sense. The major urban areas are at the high end of the income, median household income. So yeah, that's that spatial distribution. Now, we've got the data again here, and I want you to go ahead and symbolize this one now. And let's use a different classification scheme. So if we go back into the symbology, we want to classify it using graduated colors. Again, we don't want area. That's ridiculous. And instead of Jenks, let's do quantile. So you should remember what quantile classification is, and you should know this from the reading. And if you don't, stop right now and Google it and make sure you understand what a quantile classification is. The lecture slides go through this. This is really important for this week. You're going to have to demonstrate a full understanding of these different classification types. We covered this in the 2 GIS classes as well, so you should have had some experience working with these different classification schemes. But please take the time to understand these if you don't already. Okay, so here's quantile, and it gives you, basically your legend. But here's the histogram. So the distribution hasn't changed, but the classification scheme has. So look at the spread of this largest class and even the lower one and how compressed these middle ones are, obviously, okay? So over here, one thing you can do is, and I always have to look for it, it's under appearance, the swipe feature. You have to actually turn this guy on. Okay, so we're displaying the natural breaks on top of the quantile. Oh man, I've got a computer slow down here. Okay, so we can see using the swipe tool the difference here, and you see that we get an exaggeration of those upper incomes. Very different look. And if you were to pick a county at random, I think it'd be interesting, to see where it falls in this range, depending on how you're classifying. The overall pattern is going to tend to make sense because we're going to see these clusters in the urban areas. All right, let's try a third classification scheme. Okay, that time I just clicked on county instead of the ACS layer itself. This is probably a good time to go in and remind ourselves what these are. So this is county level, but this is the natural breaks. And this one, if we turn this off, this one was the quantile. And then we'll play with this one now. So going into the symbology for this layer, just verifying that we still have the correct field. So we're for sure comparing apples to apples. Let's use geometric interval. Take a look at the histogram. That's pretty interesting. We get an even more intense, a real downplaying, but more intense look at the highest income counties. Let's take a look at kind of a good idea, I think, the standard deviation. So what does this do? Notice here that the average is centered in this middle class. It defaults to 7 classes, but here we want to use a different color scheme. In this case, we want to use a divergent color scheme. And notice that ARC actually does center the mean right here in the middle, our neutral color. So the standard deviation is going to show us counties that are how far away they are from the mean. So using standard deviations, the classes are, it's just too many words to say out loud, but you can see the classes as we move away from the mean, how many standard deviations we are from the mean. So the high values are green for money, and the low values, the ones that are farthest away from the average, are in brown here. This is a pretty cool way to show this data. And it's nice that ARC makes the calculations for us. So this is showing us, the counties that are well above average, median income, and the counties that are well below. Not a lot of the very, very darkest, huh? So that's interesting by itself. Actually, did we look at the histogram? Oh yeah. Yeah, so much smaller, lowest class than the upper. Yeah, that's pretty interesting. Okay, so that's that. And again, we can use the swipe tool to display the differences between these.